When we first started applying AI at CCR, we did it by building bespoke tools. One problem at a time, we ground it out, and we've come a long way since. The tools we're about to show are just a few of the many we've built, but they tell the story of that journey. Along the way, we built things like an automated ingestion application. It takes project documents, generates the disruption and delay events out of them, and lays those events out on a timeline. We produced a design comment agent as well, and that one's had a lot of traction. It's been deployed and used on a handful of projects now. It's come a long way. We started with a simple RAG application, then we moved to hybrid search and re-ranking. Then we brought in graphs, entities, and the relationships between them to sharpen the retrieval accuracy. So, what does it actually generate? It starts by ingesting the design review comments, either retrospectively at the end of a project or live while the reviews are still coming in. And each comment thread gets a predetermined category: minor NCR, major NCR, preferential engineering, observation only, and so on. Some of the outputs include a dashboard where you can see the categories and the other metrics, the distributions by discipline and by design phase, plus the full categorized register, and an insights report, the common themes like drainage, the biggest recurring theme on one project at 38 NCRs, the trends across review gates, like major NCRs peaking at 42 at the 85% gate, then dropping to 0 at IFC, relabeled, not resolved, fault attribution, and the claims worth pursuing. Where the tool sits today is fairly impressive. The agents don't just pull the relevant information out of the contracts and specifications. Every project gets its own configuration, the categorization prompt, the severity rules, and the project's specifications indexed as a vector database. Thousands of searchable chunks, from pipe bedding through to electrical and water mains. All of it set up once per project. They can also recognize when separate comments are really the same underlying issue, so similar comments end up classified the same way. That memory lives in a project wiki. Recurring issues become nodes in a knowledge graph, each holding its precedent comments. And where precedents disagree, nothing gets resolved silently. Every conflict is queued in an audit tab for a person to reconcile. We built a claims agent as well, which helps produce claims. It works from whatever you supply, the contract, programs in XER format, site diaries, correspondence, and takes all of it into account when drafting the claim, entitlement, causation, and quantum, each assembled from the evidence. And there's a P6 program analyzer. It leverages AI agents to perform schedule and delay analysis directly on the raw XER files exported from Primavera P6. Ask it a plain English question, and it passes the program, runs a deterministic CPM cascade, and returns a reasoned, evidence cited impact report. It now offers 6 analysis modes, each aligned to the SCL delay and disruption protocol: delay tracing, schedule health checks, baseline versus update comparison, Windows analysis, as built longest path, and concurrent delay testing. And because every mode is callable through an API, the analyzer doesn't need a person at the keyboard. Other agents can invoke it as one link in a larger workflow, fanning out multiple delay scenarios across multiple programs concurrently and handing structured reports to the next stage. Here it is, tracing delay through to particular activities. Ask what a 50-day slip does to practical completion. It cascades the delay through the program, shows 49 days absorbed by float, completion moving just one working day, and saves the full reasoned report. Or it compares multiple concurrent delay events to work out which of them actually bite on the milestone or the practical completion date. Here it weighs an employer design delay against a contractor steel pile delay, cascading them in sequence, the SCL protocol approach, and lands on the effective cause in minutes, not days. We've covered a lot of ground since AI arrived, and somewhere in that process, we came to a realization. The first step, interpreting and organizing the project documents, is the foundation everything else rests on. Consolidate and index a project properly, and anything we want to do after that becomes possible. That's where we are now. We've reached the point where we can bulk process an entire project's documents, everything sitting on SharePoint, say. And once those documents are fully digested, the extracted information is stored in hybrid form. One half is a knowledge graph capturing the entities and the relationships between them, parties, contracts, events, delays, correspondence, drawings. The other half is a vector database holding embeddings of the underlying text for semantic retrieval. And with that in place, there's a whole range of work we can do on top of those documents, reviewing existing claims, working out which claims could be prepared but haven't been yet based on the project documentation itself, preparing expert reports, preparing extension of time and disruption claims, and so on. That brings us to what we're calling CCR project health triage. Depending on the size of the project, we can work through the whole thing in roughly 2 to 3 weeks off the back of what we've built and come out the other side with a set of reports for the project team. Those reports tell them how strong their existing claims really are, which claims they should be pursuing but haven't put together yet, and what issues are likely to surface down the track based on everything that's happened up to today. And those three reports are really just the first thing we do with the data, not the limit of it. Once a project is fully ingested, we can turn around almost any report you need, whatever its purpose. Take a claim that has to be corroborated by reconciling hundreds of cost spreadsheets. Normally, that's weeks of manual work. For us, it isn't, because the reconciliation has effectively already been done. Take registers, for example, hundreds, even thousands of them, payment schedules, weekly tracking sheets, forecast sheets. They're ingested and stored deliberately, similar sheets grouped together, smaller ones captured in full, larger ones as metadata, and their top rows. So every one of those spreadsheets was read, structured, and linked back to the events and documents it relates to at the point it was ingested. That's what makes the triage tool different. The hard work happens up front, once when the information is organized. Generating a report after that is a matter of asking the right question of a structure that already holds the answer. And that's exactly the kind of task AI does quickly and reliably. So, what you're buying isn't three documents, it's the organized record of your project sitting underneath them. And with that in place, the next report and the one after that costs a fraction of what the first one did. And because the data sits in that hybrid structure, the graph and the embeddings, every factual statement in a draft is linked back to the document it came from. Nothing is asserted without a source attached to it. That matters for two reasons. It keeps the AI honest. A statement that can't be tied back to a document doesn't survive. And it changes the review job. Instead of a reviewer having to go and re-establish where each figure or date came from, they click through to the source and confirm it. Checking the work becomes far quicker than doing it, which is exactly the position you want a senior reviewer to be in.
I just want to take this opportunity to actually show you two reports that were generated by prompting agents off the back of this graphical database. Unfortunately, I'm going to have to blur out pretty much everything, as these are real reports we've drafted for real clients, but you can still see the shape of the work. So the first one is a claims review for an extension of time claim. It assesses the claim against five criteria: entitlement, the settlement deed, critical path, causation, and quantum. Scrolling down a bit, this section here is the claim submission and the quantum trail. So every notice, every claim update, and how the claimed days and dollars moved over time, all reconstructed from the record in date order. Now down to say section 3 here, and this is the section analyzes the section which analyzes the contractual entitlement. It takes the facts collected on the claim and tests them against the actual contractual clauses, quoted verbatim from the executed contract. Every factual statement is referenced back to the document it came from. So if I scroll back up to section 2, as you can see, if I click on that, the reference here, what will happen is that the original document will open. And where the record has a gap or a contradiction, what will happen is that the report will actually log it. It will never fill the silence with an assumption. Okay, so let's look at another report. So the second report So what it does is that it basically gathers the factual evidence to support a disruption claim under three heads, which is late design, late free issue materials, and late access. So if I scroll down and let's take a look at the, let's say, section 2.2, the evidence table. So what you're looking at here is each head gets an evidence table like this one, which is what we're looking at. Every row is one piece of evidence: the date, the document reference, what it actually shows, a grade for how contemporaneous the record is, and a citation linked to the source. Now, similar to the first report, if I click on that reference there, same thing, one click will take me to the original document. I guess all in all, each of these basically took, I think, between 5 to 8, 9 minutes to generate. The agents basically traverse hundreds to thousands of documents to fetch exactly what each report needed. And every fact was synthesized and verified by like over 100 subagents. That's why there's no hallucination in there in these reports, and nothing gets in unless the record supports it.
The other half of this is the models themselves. We aren't simply putting our data through a general purpose chatbot and hoping for the best. Instead, we use a mixture of models, some closed source, some open source, including models we've fine tuned to perform specific tasks, like a QS drafter, one that's been trained on how a QS actually reasons, how a claim is built, how entitlement is argued, how an expert report is structured, and the standard of evidence it has to meet. The result is that what comes out reads like something a professional would have drafted, rather than something that needs rewriting from scratch before anyone outside the business could see it. So that's the journey so far: bespoke tools on one side, our own fine tuned models on the other, and the organized project record underneath it all. We started one problem at a time. We're still building that way, and this is what it adds up to.